My name is Vishal Sharma and this is the demo for Automated Cocktail Maker, my project for SIT 210. My team's project is a machine which creates cocktails or mocktails for the user. The user can browse the menu to order a desired drink through a touchscreen based user interface. After this, the machine will create the drink for the user instantly. These are the components required: a Raspberry Pi, Arduino Uno, HCSR05 ultrasonic sensors, pumps, 12-volt motors, buck converters, power supply, relays, a conveyor belt. The operation of ACM is twofold: ordering, which is based on user interface, and making. First, the user can log in before entering the system, or a new user can sign up. These two functions allow ACM to keep a record of its frequent users and recommend them drink based on their previous orders. User can browse through different options for the drinks. They can select different base drinks as well as mixers of their liking. Registered users can also browse through their previous offered drinks for recommendations. Finally, the user can click on the order button to finalize the order, and the machine will create it instantly. After the order has been made, the front end outputs an order in a specific format for the machine to make the drink and deliver it. The machine directs the motors to move and stop the cup under the relevant nozzles and then turn the particular pump after the ultrasonic sensor senses the cup present under the nozzle. After each such iteration of dispensation and movement is complete as per the order, the drink is finally delivered at the end of the belt. For fault tolerance, there are basically two major considerations that we are making. First is the addition of ultrasonic sensors. The belt is basically responsible for moving the cup between different nozzles, but the ultrasonic sensor confirms whether the cup is actually present there or not, and it's not that due to some reason the cup was lifted or maybe fell down from on top of the belt. And the other thing that we took was memory load on our microcontrollers. We have used two microcontrollers. One is Raspberry Pi, and the other one is Arduino Uno. Uno takes care of the pumps, and the Raspberry Pi basically controls all the other components of the hardware. Now let's look at a demo of this project. There are multiple demo videos, and I will show them one by one.
Hello guys, so now we are going to make a second drink of the day. Again I'm going to enter in as a guest. This time I want a pomegranate drink with soda and I'm going to order it. Now the pomegranate drink is in the last nozzle. So it will go to the last nozzle, pour the concentrate. And then it will come back to soda which is on nozzle number 2 and then pour it. So our second drink is ready. Cheers. Good evening everybody. This is our video demonstration and we'll be explaining our project right here. So in this project, this is an outer shell. We have already provided a CAD model in our summation for this exact same piece. This is the holder for a conveyor belt. The conveyor belt have two motors right here which are connected to shafts, and then two wheels are connected right here, and a rubber belt rotates over it. This is just to give a support to the belt so that it does not fall off. Coming up, this right here is a 7-inch touch screen. This will be used for the user to give input of their drink. Moving inside, if we come here, we are sorry it's currently a mess, but we can tie it down later. So first of all, this is a power supply. This is a 12 volt power supply. It takes power from outside, 240 volts, and then converts it to 12 volts to power the entire project. The power from here comes first to this PCB board, which have a buck converter, and the power goes from buck converter to these two outlets. One of them transfers this to the Raspberry Pi, and the other does it to the Arduino. From the Raspberry Pi, there are multiple pins connected. These pins are for the ultrasonic sensors, which are connected right here. Then and these are connected to this PCB board. This gives us as an input, and from the output, it is connected to another PCB board right here. From this PCB board, flash. This is the PCB board which takes the ultrasonic power from the another PCB board right here, and through the output it goes to all the ultrasonic sensors connected down below. This is the power which goes from the power supply to power all the ultrasonic sensors via a buck converter. This relay module is for the motor drivers which control the belt. The power comes in from this, and the signal GPIO signal comes from the Raspberry Pi, and then it outputs it to the two motors connected down below. Then if we come back to our first PCB board, the first PCB board have more connections which are to the Arduino. Now the Arduino controls all the pumps. From here, the power then it goes output to these motor drivers right here. We have 3 motor drivers currently connecting to 4 different pumps. The down below we can see are pumps, all the 4 pumps in a row, and then these are the bottles from which the liquid is poured to the nozzles. That's it for the entire diagram. Thank you. Now we'll discuss the functioning of our entire project. So first of all, a user can input his preferable drink through this LCD screen or via our mobile app. Then the signal from this goes to the Raspberry Pi inside. The Raspberry Pi then, from the Raspberry Pi, it starts the motors and the ultrasonic sensors. It starts the motor for the belt. Once the belt reaches the desired position, the ultrasonic sensor senses if the cup is present or not. If the cup is present, it sends a signal to the Arduino to start the desired pump at the desired amount.
Let's look at some modifications for this project. The following modifications can improve ACM into an even better machine: a mobile app for user interface, an integrated payment system for the commercial model of ACM, a model which can accept multiple drinks in an order. The machine will have to be modified so as to handle drink orders by adding an arm for cup holding which could add, change cups, and deliver drinks to the user. This is the demo for automated cocktail maker for SIT 210. Thank you for your patient listening.